All right, good morning, all you Ashland folks, and also to John in London, and also to the folks that are at the Independent City Council meeting. There's 3 people in the room right now. No, I'm just kidding. Um, there's 6 now. Well, we miss you all. That's the upshot of it. So, this is 7.4 notes on the sum and difference formula. Okay, so you've all read 7.4 and you've checked out all of these crazy formulas that they have. I am not going to prove the formula in this, is it formulae for plural? I'm not going to prove them in this video, but what I will do is do some examples. Many of them are things like cosine um, alpha minus beta equals cosine alpha cosine beta plus sine alpha sine beta. Now, with our modern calculators, you're saying, why would we even need such things? You're saying this is silly. But I'm saying, well, let's learn how to do these without our modern calculators, just using the unit circle. Because we can do things like cosine of 45 degrees, no problem. What's that? You all should have this memorized, or look on your unit circle. Square root of 2 over 2, you're right. Okay, and we can do things like the cosine of 30 degrees. What's that? Somebody, big, Lexi, big voice. Square root of 3 over 2. Things like that. But what if I said to you, ew, what about cosine 15 degrees? Is it's not, I'll tell you right away, it's not half of the cosine of 30. That would be easy. What would that be? The square root of 3 over 4? Well, it's not. So that means we need something else. We need something different. Because the cosine function is not linear, is it? It's all squiggly. So if we use the above example, the cosine of 15 degrees would equal the cosine of 45 degrees minus 30 degrees, would it not? 45 minus 30, 15. Okay, we're cool so far. So then that would equal the cosine of 45 degrees times the cosine of 30 degrees plus the sine of 45 degrees times the sine of 30 degrees. Okay. And that would equal, well, we just did it. We laid them out up here. I'll leave that visible. We said the cosine of 45 was root 2 over 2 times, not plus, times root 3 over 2 plus the sine of 45, root 2 over 2 tambien, times the sine of 30, 1/2. Very good, Rodney. Equals, well, you can leave this if you want as root 2 times root 3, or you can combine them and say root 6. Sometimes it behooves you to leave them alone. 2 times 2 is 4 plus root 2 over 4. So here we have, you can go root 6 on this one, plus root 2 over 4, I think, is about as good as it's going to get. And that, ladies and gentlemen, is the cosine of 15 degrees. Now, Luke, tell me that you don't believe it. Just go with it. Luke, with a little passion, please. No, that was the most lukewarm, I don't believe it, I've ever heard. Passionate, I don't believe it. Come on, Luke. Oh, that's much better. Not. Okay, so in your calculator, make sure you're in degree mode first, check it. The cosine of 15 degrees equals, and in your calculator, it'll be some crude approximation, equals what? .966, close enough, about. Check that, agree? And is that approximately equal to root 6 plus root 2 divided by 4? It is? You checked it? Cool, man. So this works. And again, this is not a rigorous proof. This is just one time. A rigorous proof for it is available, but I don't want to take that long because that'll bore John to death. Have you had vinegar on your chips? You know what they call chips in England? Crisps are potato chips, and chips are what? French fries, yeah. So make sure before you head over there that you have that. Thanks for doing that recycling. That's so cool. Yeah. Yeah, okay. Let's try one more. Let's try one more of these crazy things because they're kind of fun. They're little puzzles you put together. Let, example 2, let alpha equal 4/5. Oh, I said sine alpha, not alpha. I'm a mess. Sorry, you guys. Back up. Let sine alpha equal 4/5 and cosine beta equal 3/5. If alpha is in quadrant 2, oh, this will be fun, and beta is in quadrant 3, find each. A, sine alpha plus beta. B, tan alpha plus beta. That's close enough. They have some more in the book, but it's too much. Okay, first off, let's review. What in the heck is a quadrant 1 and a quadrant 2? Here's quadrant 1. Here's quadrant 2. Here's quadrant 3. And here's quadrant 4. Okay, so this will be kind of fun. So let's sine alpha equal 4/5 and cosine beta equal 3/5. So then, what can we do to find these? Sine alpha plus beta. What was our identity for that? Sine alpha cosine beta plus cosine alpha sine beta. Somebody check me on that. I'll get those wrong. Sine alpha, cosine beta, cosine alpha, sine beta. That's on page, Rodney, you look, that's 589. Okay? And you have to be specific, because if you get one of those wrong, it kind of boogers them up. Yeah. Brooke, was that a yawn? You'll cause an epidemic. Have you ever been sitting like on a stage in front of a large audience, and you yawn? Have you ever done that? It's really interesting. Try it. Do a fake yawn sometime, like Ann just did, and people will yawn, lots of them, and you feel so powerful. Yeah, it's a lot of fun. It's a lot of fun. Obviously, yeah. If you all have a cue, and you all do it in unison, the whole place will be yawning. It's okay. You're just breathing oxygen. I know you're enthralled with my delivery here, so yeah. So where were we? What do I do next? So we're going to say sine. Wait a minute. We know sine alpha. So sine alpha plus beta could equal, sine alpha we know is 4/5. Cosine beta is 3/5. Plus, but we don't know cosine alpha. Is this a problem? We don't know cosine alpha. We don't know sine beta, do we? How could we find those? Recall, somebody other than Rodney, what can we use? Starts with a P, ends with an Orion. The Pythagorean identity. Pythagorean identity tells us what? Sine alpha, and I'm going to write it like this, squared plus cosine alpha squared equals 1 squared, which is just 1. So we could say, okay, we know sine alpha is 4/5. We can square it, plus cosine squared alpha equals 1. Then what? Anton, help me out. These guys are being non-cooperative this morning. Okay, so I can say cosine squared alpha equals 1 minus 4/5 squared. Yeah? Yeah, heck yeah, that'll work. Jesus, what up? What's next? Well, you can. Yeah, that'll totally work. I can do this, and I can do this. 1 minus 4/5 squared. And then I get cosine alpha equals the square root of, let's go 25 25/25 minus 16 25. No calculator up my sleeve yet. Equals the square root of 9/25. The square root of 9 over the square root of 25 equals 3/5 as the principal root. Might be negative 3/5 depending on what quadrant it's in. Okay. So that is interesting. So cosine beta and cosine alpha are the same thing. Sounds suspicious to me. But the good news is we can take this value here and plug it in here. I want you all to finish this. Now that you know the trick, you're going to need to find sine beta and then plug this in and see what it turns out as. Because I have a feeling we're up to a whole bunch of minutes already. Yeah, we're up to 15 minutes. They're going to be bored to tears if I talk for too much longer. I think when you're all done here, I will give the solution to those of you at home or not here. We were going to find on this second one sine alpha plus beta equals 24/25. Make sure that comes out right. And tan alpha plus beta equals 24/7. And you can do that, as I said, with that technique without any calculators. Okay? So let's finish that up. Make sure you can get this. I'll come around and help you, and we will end this vodcast. And we will end this vodcast by delivering a homework assignment to those of you that aren't here. So this is 7.4, page 595. 1 through, I'll do an every other odd, a real simple one so you can remember. Ooh, this is good. 1 through, oh, that's good. 55 every other odd. Okay, so that is not as many problems as it looks like. And there's some good ones. There's a musical tone one there for John in England. I hope you brought some kind of device or downloaded an app. All right, so that is it. Thank you all for listening, and I hope you're doing well wherever you're at. I need to find my recording and stop it. Goodbye.